I'm going to start off with Andre's question. They were sent before the demo even started, so we appreciate the enthusiasm. The first question is, what's the difference in a simulation between turning on and off the collision volume on the bone geo while simulating fascia and fat?
Right, so that attribute is to do with, you can only use it when your object is a closed volume. If your object's not a closed volume, you can't use collision volume. But basically, every time you have a collision volume, you want to use this attribute. So when you're doing collisions in Ziva, everything's a point and volume test. So let's do this. So these are the vertices of your two bodies. And what's happening is Ziva's checking the points of body A to see that if they're inside the points of body B. But if body B doesn't have collision volume turned on, it can't do this test. So I might have that wrong, and I'm sure James will correct me in the chat, but I'm pretty sure that's it. So for whatever reason, if you didn't want to do a volume test on body B, you could turn that feature off. I can't think of a use case for that right now, but that's what it does.
And then his next question was, can you add multiple Ziv solvers to simulate different tissue objects in a single scene? Mm-hmm. And is it possible to simulate the bicep with one solver and then have the bicep with another solver? And if so, how do you add the tissue to different solvers?
I could answer it if you like.
Yeah, go for it. How do you do it?
If you have two solvers in your scene and you want a tissue from solver A to interact with a tissue in solver B, this is really, you can introduce cycles. So I don't recommend doing this, but what you can do, if you duplicate your mesh, like say your tissue A mesh, and then you add that tissue A as a blend shape to that duplicated mesh, and then add that duplicated mesh as a bone in solver B, and then you can collide against that. But it's only one way. It won't be bidirectional, and it's you could introduce a cycle if you're not careful. So be careful.
And when you have two solvers in the scene, how do you make one object become a tissue of that solver?
You select the solver first, and then select the tissue, and then add it. There's also in the menu an option of choosing. If you select a solver, you can set it as your default solver, and then every subsequent mesh that you want to add, it will automatically get added to that solver.
Right, yeah. I can't get the embedder of that second solver. I must have done something wrong when I...
yeah, not sure.
Yeah, I've lost the second embedder, that's why.
Well, I'll go back on mute now.
Okay. Okay, cool. So yeah, that's what you have to do. For some reason, I lost the embedder that's connected. The embedder is a node. If I go up into the node editor, you get this embedder node that gets connected to every geometric object or every geometric tissue object that you have. And the embedder looks after actually deforming it, I believe. And somehow I lost that. So I couldn't find the embedder when I was making the tissue. Yeah. Okay. That was a good question.
Yeah. And then a quick question that James responded to over the chat was simply, can we add two fibers on the same muscle?
Yes, you can. Yep. It just means it's slightly, the process is slightly different when you want to create a line of action. So Ziva adds some.
What he was asking, can you fire it with two different line of action curves?
Yep, you absolutely can. So you would select, I'll just make two fibers here, make another one, so two, and then I'm going to create two separate curves. One, two, right. And then, so what you do is select the curve that you want to drive the first fiber, and then you have to select the curve and the fiber that you want specifically. So add that to the selection. I'm just doing it in the Mel box. I don't know if, I'm pretty sure you guys can see that, but, and then Ziva add muscle line of action. So you can see, did that work? I think that worked. And then you have to select the other one. And that should work. I don't know if we're... Yeah, so there's the line of action node into that fiber, and then select fiber 1. Should have one going into that as well. See line of action 2. Yeah, so that's how you do it.
And then Ken had an interesting question. If this is something that might be better responded to on the forum, we can always move it to there. But he was just asking if it's possible to create a model based on an MRI of a person's body and then the addition of motion capture data after.
Yeah, well, Ziva will ingest any mesh basically, depending, or make, you know, it's got to be non-manifold and the triangles have to be of a certain quality. But if the MRI produces closed volumes or produces individual muscles and bones, then yeah, you can convert those to Ziva objects. Yeah, but you have to have meshes, you know, and then the motion capture data, you still have to make a rig. So you have to use, you know, regular Maya rigging to drive the bones. So you would use whatever tools to drive your bone objects, and then you can attach your Ziva tissues just in the same way that I've done this basically. Hope that answers the question.
And Ken, if you need more detail on that, you can always post it to the forum, and I'm sure everybody on the Ziva team can help you. The next, Tristan asked simply, how do you calculate the mass density of an object?
I could so the software uses kilograms by meters cubed, and you can just look up for any material, you can just look it up on Wikipedia, and if it's not in kilograms by meters cubed, just do the conversion. So if they're doing it, you know, in milliliters or whatever, like you can just convert it. But yeah, like like what Andy's saying, like our default density is representative of muscle, which is very, yeah, has a lot of fluid in it, so it's pretty close to water. So I'll go on mute again.
The next question, James did provide a response, but just so we get it on the audio, it was submitted by Sean Hannon, and he asked, rather than using a line of action curve to fire the excitation attribute, could you also use a set-driven key on the bone rotation connected to the excitation attribute?
Yep, absolutely, that works. You can also do a remap value. You could make a curve info node and get the arc length if you want to manually control that stuff. Yep, and just plug that into excitation, absolutely. Great.
Then Sean Hannon also asked, when you set the pressure to 80 on the fascia, it made him wonder if we could provide a set of rangers for all the attributes that you would find useful to see a predictable and desirable result. Too often with complex attributes, when he tries to estimate a number with no idea of the range to explore, he gets frustrated by not seeing usable results.
Yeah, that's completely understandable. I mean, I think we could provide some ranges. The asset that we're delivering, that Mr. Ink guy, you'll be able to inspect that as well and see what those values are. And this would be a fairly typical setup. So you'll be able to see the values that I've used. One thing that we're kind of happy about is we don't have a huge amount of attributes compared to other things. So there's only really a limited, on the cloth, there's only about 7 attributes, for instance, or 8 attributes to play with. So yeah, but I can understand that if you don't know the units or whatever of the ranges, it can be a bit annoying.
Speaking of which, I hadn't mentioned previously, but well, I mentioned it in the previous live with Ziva chat, we are going to be making Mr. Ink, the character that you see on the screen right now, available for everybody. So you can follow along, and you can always watch back on the live with Ziva chats when we post the videos, and you can practice and on the actual asset that you see on the screen. We'll be posting that on Friday, so you know, check your inbox because there'll be links to it. Let's see. Our next question was, I'm going to go to from Chris. He says, for muscle and skin sims in Ziva, like other simulations, do you have to model in a T-pose for some of the frames? And if so, ideally, how many frames needed to settle in its anim pose?
Yep, so it's probably best to do it in T-pose or A-pose, because if we go back to this, if you model the arms, the arms down like this, and your torsos like this, then Ziva has a hard time. What ends up happening is because the tets are slightly bigger than the mesh, you have to have very, very fine tets in order to get the in order to have the surfaces separate correctly when the arms come up. But if your arms are in T-pose or A-pose, then that gets around that problem. So it's easier for the tet mesh to kind of do its thing in there. It's my badly drawn tets. But yeah, so you want to do that. There's a second part to that question. What was it?
Yeah.
Oh, how many frames? How many frames to settle? Yeah. Well, if you're talking about run up, one thing you can do is to move the character into world space. So you have your character, like this at origin in T-pose. And the idea is that you move the character and the solver into world space, which is maybe way over here somewhere, over one frame. And you can do that because when you move the solver, it negates all the world space motion. So all the Ziva simulation is relative to the solver position, I guess. So you can do that over one frame. And then, yeah, I don't know, 10, 15 frames to go into animation start pose, something like that. Yeah.
And then I don't know how to pronounce this, but Sepulveda asks, let me see, how work the substeps? How can you make the substeps have a better how to set up substeps to get a better simulation, and how can you use the .py code to speed up that process?
Substeps are going to give you, they're going to allow for a couple of things. So more, if you've got quite a fast motion, if I was talking about the point in volume collision test. So if you don't have enough substeps, sometimes, I'll just draw it here. So you have body A and then body B here like this. This might be a bone and a muscle. And then if you move it, if this muscle moves really fast through here, the points are going to get confused. So you're not going to know, like this vertex here, for instance, doesn't know which side of the mesh to project out on. So you need more substeps in order to just step through, so you get enough time to work out where these things should be projected. If that makes sense. So I mean, that's really a trial and error process as far as I'm concerned. And so the other thing that substeps give you is you get more rich motion. So you can think of it, higher substeps as kind of being like simulation resolution, if you like. So with one substep, it's quite low resolution. Your result's going to look a bit damped, but yeah, that would be the fastest. So those are two things to be aware of. I'm not sure how that relates to the PY file. I'm not sure what that is.
And then the, these names are hard to pronounce. Iscribe. Do you use fixed attachments from muscle fascia, from muscle to fascia, fascia to fat, and fat to skin?
Well, when you're at the fascia level, so one thing we're moving towards now is coupling the fascia and the fat at the same time. So these are split apart, but they're actually, these two here are actually one pass. If I move this out of the way. So the cloth interior layer, you kind of want to minimize the number of attachments you're using at the fascia level. So if I hide this, you're going to want to have attachments around here at the border edges, but you want to see how far you can get without having any attachments first. And then when you start to get the performance right with your rest scale and pressure values, then you can look at adhesion lines and things like that if you want to limit the amount of sliding. And you'd use a fixed attachment to do that. Sometimes if you have fast motion and you don't want to use 12 sub-steps, you can use a sliding attachment to help the collisions resolve, or help do that work. In which case, say for this, you would select a couple of vertices like this on the pec, and then you'd shift select the fascia and make your sliding attachment like that. And it's important that you do it that way around, because with sliding attachments, the source object, which in this case is the object that you paint vertex selection on, the sliding attachment is locked to those vertices. So, and then the idea is that the attachment or the sliding actually happens on the target object. So if your fascia is the source object, it can never get off the pec, if that makes sense. It won't be able to traverse onto the other meshes. So it's important that you have when you make sliding attachments to the fascia, that your muscle or bone objects are the things you make the selection on first.
Right. And then the next question is from Jay DiCarlo. He asks, in the case where you use multiple solvers for whatever reason, is there currently a way to manage the order of the solves?
Well, with the stuff James was suggesting, when you have a bone connecting the two solvers together, you're just leaving it up to Maya to execute the graph in the right order. As far as I know, I don't have any more information on that. I don't know which solver will get executed first. I'm not sure what the use case is. Maybe if James is there, he might have something else to say.
Oh, he followed up a couple minutes later saying, in the case where you use multiple solvers, oh wait, that's the same one. Blah, 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 blah. Another studio that has a similar proprietary solver would use solver ordering to allow you to break up the solves for, say, a separate leg muscle solver. And the solver ordering would allow the fascia to come after all the previous solvers.
Right.
I could jump in. So yep. My response to that was, we're not doing anything about ordering solvers. We leave that up to Maya's dependency graph sort of because all of our internal work we don't do typically with lots of different solvers in the scene. Like we'll do big passes where we're solving everything inside of one system. But that is something that we could consider doing in the future for sure.
Yeah, that said though, you can do separate solves for instance, if you just wanted to do one leg at a time, you could, for instance, disable all the tissues that are not the left leg, for instance, and solve them as one thing, and then you would do that as a script or do it on the render farm or whatever. And you could parallelize that process as well, and then assemble the bakes and then run your fascia after that. You wouldn't have everything in one scene in that instance though. So.
Then Tristan asked, well, it says, what is the way to the face rig with Ziva? But I'm guessing, how do you set up and most effectively do a face rig with Ziva?
Yeah, so there's I was going to get to that today because there's been quite a few questions, but I have a scene that I could show just quickly, some of that process if we want to do that.
We got 15 minutes left.
All right, cool.
How about, what if we go through the last 2 questions that are on here, and then with whatever remaining time, you can definitely go into all the face stuff, since I know there was a lot of questions submitted regarding that on the registry form. So does that work?
Yeah, go
cool.
For it.
So in the meantime, from Kaboom's iPad, he says, how are you handling high velocity action shot simulations?
So that's one attribute that I didn't show. So there's a really, really useful thing in Ziva called inertial damping, which helps with that exact problem. It's a really, really powerful feature. So if I select the driver bones and actually, I think if I, okay. What I'm going to do is do a really fast, just a quick motion over a few frames here. So 3 frames. See, clear. Right. What happened to my? Okay. Don't know why that, I think that's a draw problem. The reason that's not updating. Oh, there we go. So this is the kind of thing you're talking about. If you're going through a really fast motion and you end up with the muscles dragging out like this. So we have a feature on the tissues and it's called inertial damping. And it's it takes a float value between 0 and 1 and it's on every tissue node, which you get when you make the tissue by default. And so if I set this to, takes a float between 0 and 1. If I set them both to 1. And play this back. You're going to see that the now that there's no the reason these bones are updating, that's a draw thing. It's nothing to do with that. I don't know why that isn't following. But you can see now that over the fast motion that you're not getting that drag anymore. So this will actually take a float. So you could make it sort of 50% of the motion. 0.5. Play that back. So you can see that if I scrub the timeline, that the muscle does, you get the secondary there, but it's not as much as the first time I did the sim. So the cool thing with this is it's not damping like regular damping. It's not going to look like it's moving through molasses or whatever. It's still going to, it's just, what's actually happening is it's negating the world space motion out of the tissue and just leaving the local stuff. So all the firing and all that kind of stuff, gravity, that's all going to happen at the usual rate. But yeah, the inertial damping is just going to pull out the inertial world space motion. So this is a really powerful shot tool. And you might have a couple of versions of the rig. For instance, you might make, say, for the lion, you have a version. I had a version for the walk cycle, and then another version with different inertial damping values for the run. And that's just a really powerful shot tool. So it's worth mentioning. It's a good question.
And then, yeah, his next question was, are you able to parent the solver node under the collisions to eliminate translation and rotation to then have more control over the fields?
The fields? I'm not sure. Is that? Just trying to find the text. Can you read it again?
Yeah. Are you able to parent the solver node under the collision to eliminate translation and rotation to then have more control over the fields?
Um,
Kaboom, you want
not,
to.
I'm not quite sure what under the collision means or the fields, but yeah, you can move the solver node around. You have to, it's not going to work if you, I believe, if you parent it under another transform. You have to parent constrain it. So it needs the values, I think, in the flowing into the transform, translate and rotate attributes. But yeah, you can move around the solver as well, and it's gonna help do the job of negating the world space motion. But the problem is if your solver starts rotating over a few frames, it's gonna do weird stuff in terms of the muscle, because it's going to change the direction of gravity and that sort of thing. So yeah, I would use inertial damping to negate world space motion.
And then his remaining, I think he has 3 questions left. Can you sim locally on a single frame to test out the geometry placement? Oh wait, no, sorry, it's 1 question with 2 bullet points. So can you sim locally on a single frame to test out the geometry placement for 2 reasons? 1, to test out geometry for interpenetrating geometry, and then 2, to get a proper start frame to get around run-up issues.
Yeah, so if you're looking to do things like resolve intersections at rest, for instance, you could just solve 1 frame, have Ziva resolve the intersections, and then use ZBuilder to copy all the Ziva data, so all the attachments and the muscles and all that kind of stuff. And then you have to duplicate the geometry and then rebuild the setup using ZBuilder on the new position at start frame. And that's probably the workflow for doing that.
Great. Then it's actually our last question is from Fulvio. He says, which maybe, I guess you might be comfortable answering, but what's the recommended requirements for a machine to run a decent workflow on Ziva?
I don't know if they're, I think Essex answered this one a while back. Like any computer that was made in the last, I can't remember what it was now, 5 or 6 years should be fine. Maybe James has got some hardware.
Yeah, we can probably get Essex. Essex is one of our top developers at Ziva, and he would very much be able to answer this question. And so we can post it to the community forum.
It was already answered on the community, actually. Someone already asked that. Yeah, if we can find the link to that.
Look for the link, and if it's not already, then we will post it. Yeah. Oh, and also I missed this question from Cyril. He was asking if the mesh of the fat has to have a thickness, like a shell.
Yeah, so the fat, it doesn't have to, I suppose, but if you want to get the right, if you want Ziva to do the right thing, it should be a closed volume, because otherwise you're going to effectively tetrahedralize a shell, which is what we have here. So this doesn't have any volume outside of the tets we already have. So if you don't have a closed volume, then Ziva can't put tets on the inside of the volume, which means you won't get proper volume conservation. So the idea is that you make, with the fat, for instance, the fast way to do this is so you take your fascia mesh, or your fascia mesh, and then you project the fascia mesh back to the skin. So then you have 2 layers with exactly the same topology, and then it's really easy to make a bridge between the layers like this. So we have a script to do that, or you can make your own script. It's really easy. And then you have a closed volume. Just make sure, all you have to do is make sure that the normals are all pointing out, and then you can make it into a tissue, and you can make the tets as fine as you want, and you're going to get volume conservation properly. That said, it will still work if you don't have that, but it's not going to give you strictly the right thing. Yeah.
Oh, also James posted the thread about the hardware question.
Mm-hmm.
John's asking, is the script available? The one you just mentioned.
Sure. Yeah, we can make that available. Yep. It's not on the internet currently, or maybe someone else has made one. Yeah. It's not a particularly difficult piece of code, but yeah, we can definitely share it.
Cool. And that's actually all the questions. Oh, well, one other thing is whether or not we'll be conducting a session on couple sims.
Coupled sims. Yeah. There's no great mystery around coupled sims. It's just that you solve everything in the same scene. So with the fascia and the fat, for instance, that's coupled, if you like, in that the fascia and the fat are solved at the same time, and all that's different is that it's being solved in the same scene, and there's an attachment going from the cloth to the fat. There's not a huge amount of mystery about it. But I mean, if we need a separate video on it, we can do that. I think
a tutorial video might be more suitable rather than an entire session for it.
Yeah.
We have a bunch of tutorial videos that are coming out, and every week we'll be posting a new one, and that's definitely a topic that we can dive into. And they range from anything from a couple minutes to around 10 minutes long, so we can go into quite a bit of detail if necessary. That question was submitted by Praveen. So Praveen, if you have any specific questions you have about that, you can always submit them, and then we can be sure to incorporate those responses in that tutorial video. But yeah, so we have 5 minutes left. I don't know if you think that's enough to cover the face rig example.
Sure. Yep, I can bash through the face stuff.